You know, we usually think of AI learning as this slow, steady climb. But what if it could have one of those sudden aha moments, just like we do? Well, today we're diving into this really wild phenomenon called grokking. It's where an AI model basically goes from just memorizing facts to truly understanding them, and it happens almost overnight.
So, this whole thing kicks off with a classic AI puzzle. I mean, think about it. Can an AI ace a test, get every single question right, but still not actually understand the subject at all?
And for a long, long time, the answer seemed to be a definite yes. It's a problem we call overfitting. Basically, the model gets so good at memorizing its training data that it becomes a master, but only of that specific data. The second you throw it a new curveball, a problem it hasn't seen before, it completely falls apart. It never learned the rules, just the answers.
But, and this is where it gets super weird, researchers found that if you just keep training the model way past the point where it's already memorized everything perfectly, like when it looks like you're just burning electricity for no reason, something just clicks. All of a sudden, it makes this incredible leap from just memorizing to actually understanding.
And that sudden breakthrough, that's what scientists have dubbed grokking. It's that magic moment when the model switches gears from just mindlessly repeating facts to what we call genuine generalization. You know, the ability to take what it knows and apply it to brand new situations. It's literally the AI's aha moment. And take a look at this graph, because this is exactly what grokking looks like in action. See that green line? That's the model's accuracy on the data it's already seen. It shoots up to 100% almost immediately. Perfect memorization? Check. But look at the blue line. That's the test accuracy on new problems. It's flat, it's at 0 for a long time. And then, bam, out of nowhere, it skyrockets. That's the moment it generalizes. That massive jump is the aha moment.
Okay, so to figure out what's really going on inside the model's head, so to speak, researchers set up this really clever experiment. They gave it two totally different kinds of reasoning tasks.
Right, so they gave the model two types of problems. First, composition. This is like connecting the dots. Think Barack's wife is Michelle. And fact two, Michelle was born in 1964. The model has to chain those two facts together. The other task was comparison, which is more about weighing two things at once, like who is older, Trump or Biden. So you've got one task that's step by step and another that's all at once.
And this clever setup let them finally peek inside that infamous black box and see how the AI was learning to reason. And what they found, it wasn't just one single way of learning. It was two.
Now this is the really mind-blowing part. The model actually builds two completely different internal pathways. Think of them as circuits, depending on which kind of problem it's working on.
So for that fact-chaining task, the composition one, the model builds what's called a serial circuit. It works just like you'd imagine an assembly line. It processes one piece of info, then passes that result on to the next station.
Yeah, you can really picture it as this vertical assembly line. The lower layers of the model's network grab the first piece of the puzzle, and then they pass their answer up to the higher layers to finish the job. It's a very rigid, one step at a time kind of process.
But for the comparison task, it learned something way more efficient. It developed a parallel circuit, one that could look at both facts at the exact same time. This way is just so much smarter. The lower layers grab both facts they need at the same time, and then the upper layers can compare them directly. It's a side-by-side evaluation instead of a sequence. It's just a way more efficient way to think.
So why does any of this matter, right? Well, it matters because that first kind of clunky assembly line circuit, it actually exposes a massive weakness in some of today's most powerful AIs, the architectures we call transformers. Yeah, the very same tech that powers models like GPT.
Okay, so here's the fatal flaw with that serial circuit. The knowledge gets siloed. The information that's needed for step 2 of a problem gets stored only in the upper layers of the model.
So here's the real issue. Imagine a factory, right? The morning shift workers have their own tools and knowledge, and the afternoon shift has theirs. But they never talk to each other. So if the afternoon shift needs a tool that only the morning shift used, well, they're completely stuck. That's pretty much what's happening inside the transformer. Those upper layers can't get to the knowledge that the lower layers learned, and that's why it chokes on new, multi-step problems. And all of this discovery led to one final, really dramatic experiment. We're talking a real David versus Goliath showdown, pitting a small, specially trained Grokked model against the biggest AI models on the planet. The researchers came up with this insanely difficult reasoning task. Add a huge search space, and to solve it, the model had to chain together a whole bunch of logical steps. This is exactly the kind of thing that even the big giants, like GPT-4, are known to struggle with.
And the results? Well, they're pretty staggering. You have industry titans like GPT-4 and Gemini. Even with all the information in the world at their fingertips, they just completely failed. They scored barely better than if they were just guessing. But that small, specialized model, the one that was trained until it really grokked a problem, it did something absolutely incredible. It hit near-perfect accuracy, 99.3%. A tiny model that had truly woven the knowledge into its own structure just completely blew the giants out of the water.
So what was the secret sauce? Well, the giant models were basically just looking up answers in a massive phone book. It's a technique called surface-level retrieval. But the small model, it had actually integrated that knowledge directly into its own internal wiring. It didn't just have the information, it became the information. And for complex reasoning, that deep integration, that's what makes all the difference.
And all of this leaves us with a really provocative question for the future of AI, doesn't it? Is the path to true, genuine reasoning just about building bigger and bigger models and throwing more data at them? Or is it about designing them with the right internal structure from the start so they can actually, truly grok the world around them?
This is for entertainment purposes only.